Okay, so here's a problem that's basically very similar to one of the homework problems. So find the area of the part of this surface that lies above the triangle with these vertices. Okay, so this is the area formula we're going to use. It's the magnitude of the cross product of these derivatives, and we just take the integral over the parameter domain D. And here D is the triangle with these vertices, because what we have is we have this. So let me just draw this region. Let me just graph the parameter domain. So this is one of the triangles, or this is one of the vertices. This is one of the vertices. Okay, and so we have this surface right here. This surface right here is like one of those sort of, you know, you take a piece of paper and you sort of curve it into a U. That's what this surface looks like. Okay, and we just want the part of it that lies above this surface here. So the parameter domain D is going to be the triangle. Okay, because we just want the part of the surface that lies above. We just want the part of the surface that lies above this triangle. Okay, so now basically we need to fill in this information. So the parameterization that we're going to use is just going to be the standard one. So the surface is a graph of a function. So we're just going to take the standard parameterization for the graph of a function. It's x, y, 3y squared. This tells us that Rx is equal to 1. Oh, sorry. I'm making this problem easier than it is. Okay. Xy 7 plus 4x plus 3y squared. So our x is 1, 0, 4, and our y is 0, 1, 6y. Okay, and so I'll let y'all do this computation on your own. I'll just tell you what it is. The cross product, Rx cross Ry is equal to minus 4 minus 6y 1. And so this means that the magnitude of the cross product is the square root of the following 17 plus 36y squared. And unfortunately, there's not really a way to simplify this any further. Okay, so now the square root of 17 plus 36y squared is this part right here. This is the magnitude of this vector. Okay, so now we're going to integrate this over the parameter domain. Okay, so this line right here is y is equal to 1/2 x. And so the integral is going to be from x is equal to 0 to 2y. Y is equal to 0 to 1. This is 0, 0. This is 0, 1. This is 2, 1. And then we're going to integrate 17 plus 36y squared dx dy. Now notice that if we've done the y integral first, then we would have to find the antiderivative of the square root of 17 plus 36y squared. It's easier to do the x integral first. So in other words, go in this direction. It's easier to do that integral first, because what we're going to do, this is equal to the integral from y is equals to 0 to 1, 2y times the square root of 17 plus 36y squared dy. Now we can do u substitution, and after we do that, this is equal to 1 over 36. The integral from u is equal to 17 to 53, the square root of u, and this, if you compute this is the following, 53, this is 53 times the square root of 53. Sorry, let me just make this better. 53 times the square root of 53 minus 17 times the square root of 17. Okay, and so that is how you do this. The new part is getting the integral to this point. Okay, if you can get it to this point, if you can get the integral to this point, that's really good. So by this point, I mean having the right order of integration, okay? Because on the exam, that's one of the things I'm going to test. I'm going to test, are you able to recognize that you need to switch the order of integration to do the x integral first rather than the y integral? Okay, but after that, you just do it however you want to.